Download this code from codegive.com, link in the description below. Running a private Chroma vector database locally is a great way to manage and query high-dimensional data for tasks such as machine learning, recommendation systems, and more. Below, I'll provide a step-by-step tutorial to set up a Chroma vector database in just a few minutes using Python. What is Chroma? Chroma is an open-source vector database designed to work with embeddings and provides functionalities for storing, searching, and analyzing vectors. It is designed for scalability and ease of use. Prerequisites: Python 3.6 or higher. Pip for installing packages. Step 1. Install Chroma. First, you'll need to install the Chroma library. You can do this using pip. Step 2. Set up your environment. Create a new Python file, example chroma_example.py, or open a Python interactive shell. Step 3. Import required libraries. In your Python file, start by importing the necessary libraries. Step 4. Initialize a Chroma database. Set up your Chroma database locally. You can choose to store the database in memory for testing purposes or persist it to a file. Step 5. Create a collection. Now, create a collection to store your vectors. Step 6. Insert vectors. Here's how you can insert some sample vectors along with their corresponding metadata. Step 7. Query the database. You can now query the database to find the nearest vectors to a given example vector. Step 8. Persist the database. If you want to persist the database, you can call the following command before exiting the program. Step 9. Run your script. Run your script using the following command. Conclusion: you've now successfully set up a private Chroma vector database locally. You can insert, query, and manage your vector embeddings efficiently. This setup can be useful for various applications, including search engines and recommendation systems. Additional notes: make sure to explore the Chroma documentation for more advanced features like filtering, metadata handling, and integration with machine learning libraries. For production use, consider securing your database and managing the data lifecycle appropriately. That's it. You should now have a functioning Chroma vector database running locally. Running a private Chroma vector database locally can be a great solution for managing and querying embeddings efficiently. Chroma is an open-source embedding database designed for working with vector representations of data, such as those generated from machine learning models. Below, I'll guide you through the steps to set it up in under 5 minutes. Prerequisites: 1. Python 3.7 or later. Ensure you have Python installed on your machine. 2. Pip. You should have pip installed to manage Python packages. Step-by-step tutorial. Step 1. Install Chroma. First, you need to install the Chroma library. Open your terminal or command prompt and run. Step 2. Set up a basic Chroma database. Next, create a Python script, example chroma_example.py, and open it in your favorite text editor. Add the following code to set up a basic Chroma database. Step 3. Run the script. Now that your script is ready, run it using Python. Explanation of the code. 1. Initialization. The code initializes a Chroma client with a local database configuration. The persist_directory is where the database files will be stored. 2. Creating a collection. A collection is created to hold the data. This acts like a table in traditional databases. 3. Inserting data. A list of dictionaries representing documents and their embeddings is created. Each document is added to the collection. 4. Querying the database. A sample vector is defined to demonstrate how to query the collection. The results are printed to the console. Step 4, verify the database. After running the script, you can check the ./chroma_db directory. You should find files related to the stored database. Additional features. Persistence. The database persists data in the specified directory, so it remains available across sessions. Embeddings. The code uses simple 3D vectors as embeddings. You can replace these with actual vectors from your machine learning models. Conclusion. You now have a basic setup of a private Chroma vector database running locally. You can expand upon this by integrating more complex data, adding more sophisticated querying, and even integrating it with your machine learning pipelines. Happy coding!